1, given the graph below, identify the solution to the system of equations. To find the solution to a system, we need to first figure out where do they cross. If you look at the graphs in question 1, we have two parallel lines, which means they never cross. There is not a solution to a system that has two parallel lines. 2, given the graph below, identify the solution. Okay, we need to figure out where they cross. You'll notice that these two lines have arrows on the end, so we need to extend those guys out. So let's do that here. We're going to extend this out here, and we'll extend this one out here, and then we can see the point of intersection. And so let's figure out what this point of intersection is. If I go from the origin right here, if I go over 2 and up 1, 2 comma 1, that would be the solution to this system. 3, determine how many solutions. So we need to figure out how many times do these two guys cross each other. We'll grab our calculator, put the first one in y1, the second one in y2. We're going to graph it. There's the first one. There's the second one. You might assume that these have an infinite number of solutions, but if you see right down here, the lines actually separate. And you can see right here, looks like they have one point of intersection. So this has one solution. 4, identify the solution. So we want to figure out where do these two guys cross. Here is our first equation. We'll highlight it as the yellow equation. And then we'll have our light pink equation. Now you could go through and plot these points, or let's just simply look for a point that they have in common. And if I look at 5, 9 in the yellow equation and 5, 9 in the light pink equation, that would be the point they have in common, or the point that they share. And if they share one point, that is actually the intersection of those two lines. And so that would be the solution to this system. 5, identify the solution. So let's figure out and see if these two tables have a point in common. So we could call this our y1 graph, and this will be our y2 graph, or y2 table. This one's interesting because if I look here, 1, 3, 1, 3, they have that point in common. However, 2, 6, and 2, 6 they have in common. And they have 3, 9, 3, 9, 4, 12, 4, 12. In fact, these are the exact equations. And if I have two lines that are exactly the same, they have an infinite number of solutions. So you could draw a little infinity sign and say an infinite number of solutions, or you could actually write that out. 6, sketch an example of a graph of a system of equations that has no solutions. They do not intersect. I could draw two parallel lines this way. I could draw two parallel lines this way. I could draw two parallel lines in any direction, and just as long as you have two lines that never cross each other. Solve the given system. To solve a system, we need to figure out where do they intersect. Put the first one in y1. Put the second one in y2, which we've done in the calculator. Let's graph it and figure out where do they cross. Now you might make the assumption that these are parallel lines, but you can see down here, see how very wide they are apart. But as we start to move up and to the left, it looks like the two lines are starting to converge or get to one point. We just have to zoom out and see where that particular intersection is up there. So we're going to zoom out, number 3, but you actually have to hit enter one more time to get the calculator to actually zoom out. There are a couple ways to do this. The first way would be to simply just take your cursor and you could get it close to the intersection, and you'll notice here that it's going to give you some nasty looking decimals, and then you would just have to round your answers. Or we can actually use the calculation feature in the calculator here. Second calc. We want it to calculate the intersection, number 5. And all you have to do is get your blinking cursor close to where you think the intersection is, and then go enter, enter, enter. And it will tell you the actual coordinate. So this coordinate is -6, 30. That is the solution, or where the two lines actually cross. 8 says find the y value of the solution. Okay, we have them in y1 and y2. We're going to graph it. Let's calculate the intersection. Second, calculate number 5. Get the blinking cursor close to the intersection, enter, enter, enter. Let's extract that coordinate, 2, 5. But the question is asking what is the y value of the system, or in this case, the y value of the solution. Well, the y value would be 5. So our answer is 5. 9. The second of two numbers is 4 more than the first. Okay, I know I have two numbers. We have a first number we'll call x. We have a second number. Let's call this number y. Now let's go through and see if we can write a system here. So let's start back here. The second of two numbers is. So the second number y is 4 more than the first. So that means it is 4 more than the first. There's our first equation. Let's look at our second equation. The sum of these numbers, and there's a typo here, is 56. How do you find the sum? We add them together. So the sum of these numbers is 56. This is our answer. All it wanted us to do was to write a system, and we did. 10. One wall inside a shoe store is used to display walking shoes and running shoes. So here we go, walking and running. There are 135 pairs of shoes in the display. So what that means is that the total number of walking shoes and running shoes together is equal to 135. The second part of this says there are 1.5 times as many pairs of walking shoes as there are running shoes. So that means the walking shoes is actually more than the running shoes. So whatever number we get for running shoes, we're going to multiply it times 1.5. That will equal the number of walking shoes we have. So we have to figure out what number can we plug in here, multiply it times 1.5, and take that number and plug it in for W. But when we do, when we add them together, we get 135. Well, you could write a system and solve for it, but in this case, I'm just going to show you a little guess and check method. We're going to take the number 54 here, and we're going to plug it in. Oops, let's plug that in for running. So we're going to take 54. We're going to take that number, oops, multiply that times 1.5, so 54 times 1.5, and we get 81. So let's see if 54 and 81, when we add those together, does it equal 135? And it does. And so let's go back and let's look at the two constraints. The first constraint was that when we add these two numbers together, it has to equal 135. But when I take this number here for running shoes and multiply it by 1.5, it has to equal this number here. And it does. And so since it fits both of those constraints, let's look at the question. How many pairs of walking shoes? There are 81 walking shoes, 54 running shoes. 11, solve the system. You can't solve a system using y equals unless both of your equations on paper are in y equals. These two are not in y equals. Let's start with this first guy and do our little, what we call move divide. We're going to move this guy to the other side by doing opposites. It becomes positive. This one is good to go. We have it in y equals. Now we're going to come over here and we're going to do move divide with this guy. Take your x term and move it to the other side. Since it's positive on the left, we're going to make it negative on the right. Bring down your negative 5y. Your last step is going to be to divide by the coefficient in front of y. Divide by negative 5, divide by negative 5, divide by negative 5. You are left with y equals a negative 1 divided by a negative 5. That's actually positive 1 over 5, x. And a negative 9 divided by negative 5. That's going to be a positive 9 over 5. Now we're ready to type this in y equals. I will be honest with you. If for some reason you can't do this part right here, so if I were to rewrite this as y equals negative x over negative 5 minus 9 over negative 5, you could actually type that in y equals and the calculator will clean it up for you. Let's graph these two here. We'll start with the first one, x plus 5. Start with the second one. We'll create a fraction key, 1 over 5 x plus fraction key 9 over 5. And it says solve it. We're looking for where do they cross. Let's see if we can do a visual inspection to where they cross. It looks like they cross over here. So let's calculate here. Second calc, number 5. Get the blinking cursor close. Enter, enter, enter. And we have -4, 1. That is my solution to the system. 13, solve the system. This guy is good to go. It's in y equals. However, this one is not. We're going to do our move divide, move the 2x to the other side by doing opposites, bring down the y. Now we're in y equals. Put both of them in y equals, and we are going to graph these. And let's see what we have. Our first line, our second line, they're parallel. How do I know they're parallel? If you take a look here, this slope is -2, and this slope is -2. Same slopes mean they are parallel. So where do they cross? They don't. No solution to this system. 14, find the x values. So that means we need to figure out where do they cross. We'll get a coordinate, and then we need to know what is the x value of that solution. Looks like one of these guys is already in y equals. We're good to go with that. However, this one is not. We're going to do our move divide. 3x goes to the other side. It becomes opposite. Bring down the 14. Bring down -2y. And divide everything by the number in front of y. That's our coefficient. Divide by -2. Divide by -2. And again, you could type this in right here, this guy right here, into y equals if you wanted to. However, I'm going to clean it up. Y equals a negative divided by a negative gives me a positive fraction. Then to look at the second part, a positive divided by a negative is going to give me a negative fraction. In this case, it would just be a negative whole number. Let's type these guys into y1 and y2. It doesn't matter what order. Have the first one typed in. Let's fraction key this 3 over 2. And we have x minus 7. Let's do a visual, see if we can find out where do they intersect. We see that. Let's calculate it. Second calc intersect number 5. Where's my blinking cursor at? There it is. Get it close. Enter, enter, enter. I'm going to write down the actual solution. 3.3 repeating, comma, -2. Go back to the question. The question said find the x value. So my answer would be 3.3 repeating. 15. The number of calories in a pecan pie is 20 less than 3 times the number of calories in a scoop of ice cream. Let's use some variables here. For pecan pie, let's use P. We'll say P for pie, and we'll use the letter I for the ice cream. All right, so let's go back and let's reread our first sentence. The number of calories in a pecan pie, so the letter P is 20 less than. You have to be careful. Less than is a switch word, which means you want to subtract backwards, so to speak. 20 less than 3 times the number of calories in a scoop of ice cream. So 20 less than means you need to take away 20 at the end of the problem. Let's keep reading. The pie and ice cream together, P plus ice cream together, all have 500 calories. Write a system. That's what we just did. We wrote a system. There is our answer. 17, if you cut through all of the words, get down to the actual question, how many cases of chocolate bars will this company need to sell in order for costs and revenue, these two guys, to be equal? Well, where costs and revenue are equal, that is actually where they cross each other. So it looks like they cross somewhere over here. A couple of ways of doing this. The first way would be to extend your two lines out, extend your x-axis out, and it looks like they're counting in increments of half on the x-axis. So we're at 3 3.5, 4, 4.5, 5, 5.5, 6. We could probably make a conclusion that it's going to be about 6,000, right? Or we could graph these two and figure out where they cross. So we'll graph it. Instead of using 30,000 plus 5x, since this is the y-intercept, I'm just going to use 30. So 30 plus 5x and then 10x. Graph it. I do not see anything. So I'm going to have to zoom out. So zoom out, number 3, enter. Do I see anything? Oh, let's try it one more time. Zoom out. Oh, let's try it. Zoom out. Let's see if we see, there we go. We kind of see an intersection up here. Second calc, number 5, get it close. Enter, enter, enter. We're looking for an x value because the question was asking how many cases. So how many cases do they cross? And if you look right here, it would be 6. It would actually be 6,000 cases. This is in thousands. Good luck.